The probability histogram for discrete random variables. When the possible values of a discrete random variable are evenly spaced, the probability mass function can be represented by a histogram with rectangle center at the possible values of the random variable, as we can observe in this plot. The area of the rectangle center at that value is equal to the probability of that random variable. Such a histogram is called a probability histogram because the areas represent probabilities. Let's construct the probability histogram for the number of flows in a wire. The probability mass function for this problem is given by the probability of 0 flows equal to 0.48, the probability of 1 flow is equal to 0.39, the probability of 2 flows is equal to 0.12, and the probability of 3 flows is equal to 0.01. To construct the histogram, we draw a rectangle centered in the random variables and whose area is equal to the probability of x being equal, in this case, to 0. We continue doing the same for all the random variables in the sample space. Now, how do we convert a frequency diagram into a probability histogram? Let's consider this case in which we have 200 sample, n equal to 200, and the frequency of the first variable is 60. The frequency of the second variable it is 100, and the frequency of the third variable is 20. To build the histogram, we divide the frequencies by 200 and we obtain the corresponding diagram. So in this case, the height of the first beam is going to be 0.3, the second one 0.6, and the last one 0.1. In such a way, the total area is equal to 1. So 0.3 plus 0.6 plus 0.1 equal to 1. The thickness is always equal to 1. Now we are back to the bulldozer example. 3 bulldozers are selected. Each one has 50% probability of being operational. This figure represents the possible outcomes. We can observe that the first outcome has bulldozer 1, bulldozer 2 and 3 operational. In the second case, bulldozer 1 is not operational, bulldozer 2 and 3 are operational, and so forth. This represents the total sample space. And the size of the sample space is 8. Now, we can define a random variable in the following way. Let x be the number of bulldozers that are operational. So in the first outcome, we have 1, 2, and 3 operational. In the second outcome, we have 2 operational. In the third outcome, 1, 0, 2, 1, 1, and 2. So therefore, the range of x is equal to 0, 1, 2, and 3. Now the frequency of each one of the outcomes, it will be, in the case of 0, we have only 1. In the case of 1, we have 3. 1, 2, 3. 2 also has a frequency of 3. And 3 has a frequency of 1. The probabilities will be, in the first case, 1, 8. In the second case, 3, 8. 3, 8. And 1, 8. So the total probability is going to be equal to 1. 1 plus 3 plus 3 plus 1 is 8. Divided by 8 is equal to 1. To build the histograms, we can start by plotting the frequencies. For variable 0, we have 1. For variable 1 we have 3, for variable 2 we have also 3, and for variable 3 we have 1. So we select rectangles around the variables whose thickness is equal to 1, and to convert into probability histogram we have to divide by the total number of outcomes, which is 8. So in the first case it will be 1/8, in the second case 3/8, in the variable 2 it will be 3/8, and in the variable 3 it will be 1/8.